the packet. If you weren't here, you didn't get one, obviously. No? Did you get it? Maybe? You did. Oh, I thought you said no. You didn't get one here? Okay. Okay.
These ones are.
Jake, you get one?
Yeah, I got one.
You got it? You just don't have it out? Did you get one? Yeah,
yes.
You're good? Everybody else? Good? 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 All right. So, here's what we're going to do. I let you guys try to figure out what you wanted to do, whether you wanted to finish this one or start working on your take-home test. Remember, due by next Monday. So I'm hoping that you guys have been working. I gave you that extra couple weeks on it, so kind of keep that in mind. So what we're going to do today is kind of go over, review for a moment, and then kind of come back and answer some of these questions. My game plan is to test on this on Monday. So we have this week and the weekend to kind of work through it and make sure you get it. Okay? So I talked about the fundamental theorem of calculus. I didn't give you the name of it, though. Yes?
Is the take-home test going to be on the grades for third quarter?
My game plan is, it looks like they end on the 15th, I think. And if I can get it by that 13th, then I'll put it on.
Okay.
Yes?
Is it pages 187 and 189?
That is a really good question. I think so. Or 178 and 1, I don't know. 170, 187. Yes.
Okay.
Okay.
187 what?
To 189.
Really? Are you just asking now, you guys?
Hey, what?
You're going to make me cry. It's a lot of questions. We've had since January. Whew. Okay. So, here we go. So, what we're going to be working... Now they're arguing about the questions. I love it. So, what we're going to be doing today is we're going to review for a moment. Okay? If I have an A and a B, I don't need
a C.
A C. Why not?
Because he just said that.
Because I said it. I made it up.
You don't need a constant.
I don't need a constant because it's called a what kind of integral?
Definite.
Definite integral. 100% definite, right? So we know it's definite rather than indefinite. So if I'm working these problems, I know that the final result, as I'm looking at it, is going to be the function of b minus the function of a. What's cool about this, right, is that you actually are able to take an integral. I've taught you how to do that now. It's just kind of putting it together. And the one thing I neglected to tell you the other day is this is what we call the fundamental theorem of calculus. Okay? The fundamental theorem of calculus. Yes.
So when you have B, A, F prime, that's F prime of X.
Correct. And so, you know, when I put F prime, I'd have to have the dx attached. Did you notice that? Because
Right.
this is the derivative, right?
But you can take the integral, just a regular function.
Which, yes, and you're putting a dx attached to it to say it's a derivative. Okay? Air quotes, right?
So sometimes they'll give you the function, sometimes they'll give you the derivative.
100%.
And if they give you the function, you just have to attach the dx.
Correct. Yes.
Alright, so like in a problem where you gotta use that to find the area of the thing under it, and they give you the equation of the actual line of the curve.
Right.
What do you do from there?
Well, you're going to say that the line of the curve is this guy right here.
Okay.
We're going to call it a derivative. That way we can take an integral of it. Remember when I'm using this formula, I told you that you could find the area under a curve, which is rather cool. But not only could you do that, but I also kind of introduced you a little bit and told you that position, velocity, acceleration, if I take an integral of the acceleration, I get velocity. If I take an integral of velocity, I get position. Notice those are not like area under a curve, but it's doing the same sort of thing. And I would do that from time, like time is 1 second to 10 seconds. What is the acceleration? What was the velocity when the acceleration was this? So it has multiple ways that we utilize this fundamental theorem of calculus. Having said that, we have to just kind of make it fit what we're working with. Derivative or not, we can integrate it.
Yeah, and then once we have the integral, then we plug in
The B
and
the A.
to the integral.
Correct.
We have
Not into the integral, into the function that you get. Well, the integral, once the integral is complete, yes. I think that's what you're asking. Once the integral is complete, then you plug
so
it
once
in.
you take that, so it'll give you the actual equation, you do integral of that, and then you plug the stuff into that
Right.
equation.
Correct.
Okay.
Make sense?
Yes.
Yes.
And that was where you said like x equals 4, x equals 1.
Right. So I'm going to go 1 to 4. Now, what did I tell you guys the other day? If I put it vice versa, by mistake, if I put the big number on the bottom and the little number, I'd get a negative of my answer, right? It would be the opposite answer.
Absolute value.
It would be the absolute value, but we don't want to do that. We don't want to show them that we don't
Is it
really know.
always small?
It's always small to big. left to right is the way I always explain it. Okay, so far so good? Yeah? All right, put the phone away. Thank you, my dear. All right, so fundamental theorem of calculus, and I always try to say it's the fundamental. Yeah, I know. All right, so having said that, let's go. I know, it was kind of funny while it lasted. All right, so we're going to do number 10, November, December 2002. It's the first one on your packet. Did anybody have trouble seeing the ones that I circled? Somehow they didn't really show up, but I gave the sub directions that somebody could read them.
She told, and she said that she had the original. And
Sweet, so she handled it. Well, good for her. She said she wanted to, she said, by the way, you guys were the best class.
She was so young.
We were
So it was like,
we're so tiny. And
So
not talking.
sweet, right? You weren't talking. Well, that's probably why she loved you. And I'm not going to tell that to the rest of the classes, I promise. She did say, though, that you were excellent, that you really got down to work and you did what you needed to do, which is, I appreciate. Okay, so this thing says the diagram shows the points A is 1, 2, B is 4, 4. The curve is 2 squared of x. Regardless if it's straight or not, they're going to call it a curve. Keep that in mind. Don't get confused by that. Okay? The line BC is the normal to the curve at B, and C lies on the x-axis. Lines AD and BE are perpendicular to the axis. Find the equation of the normal BC. Nick came in a little earlier. He's like, wait a minute. There were a whole lot of find the equation of a normal line. That's not new, guys, right? Find the equation of a normal line is from last semester. How do we find the equation of a normal line?
it's the opposite.
Opposite
reciprocal slope.
How do we access it? Take a derivative, right? Plug in the x value, correct? Do the opposite reciprocal. Use my favorite formula. You have the equation of a normal line. Okay? We can go back and review that, but remember that's what's happening there. Keep that in mind, okay? Now, the next thing says find the area of the shaded region. That's new to us this week, okay? So, find the area of the shaded region. And when Nick came in earlier, I tried to explain it a little bit. Did I draw the people in there for you guys?
No.
Let me show you what I did with him. It kind of helped, I think, made sense. So if I'm looking at this, right, if I'm looking at this, what I want to know is, I want to know the area, and you guys can probably see the shading pretty well there. The shading goes from here to here, here to here. You agree? Mm-hmm. So the shading happens, I say, wall to wall, ceiling to floor. Is everybody cool with what I just said?
Uh-huh.
Left wall to right wall, ceiling to floor. So what I always do is I draw a picture of a guy in there, right? And he's very handsome. So everybody says he looks starfish-like, but I'm cool. Well, that's how it works in my family. we work it well. So we have our ceiling to floor, right? So if I look at this, I know I'm going to go integral, okay, wall to wall. So what's my leftmost to my rightmost x values?
1.
Okay, 1 is my x value here, and 4 is my x value here. Those are my A and my B. Everybody cool? Everybody get that? Okay. So we're going to go from 1 to 4. Okay, ceiling minus floor. Up until now, it hasn't really mattered. What is my ceiling in this case? My ceiling is the curve that touches my head. What is it called in this case? 2 squared of x, right? So my ceiling is 2 squared of x. What is my floor?
0.
0. Does 0 really matter right now?
No.
If I subtract 0 from it, it doesn't really matter. So truly it's wall to wall, ceiling minus floor. And everyone I've shown you so far is 0. The very top of the page, look at, scan your eyes to the top of the page. If you drew a person in there, what would the ceiling be? What would the floor be? The ceiling would be the curve, the 3 times the square root of x. And what would the floor be? The x number. So it would be, that would be 3 square root of x minus x would be what I would put right here. Okay? So it truly is left to right, wall to wall, ceiling, floor. Okay, so if I'm looking at this now, if I subtract 0, it doesn't really matter. What should I attach to the side of this to say I can now integrate? Put a dx, right? Okay, I don't know how to take an integral of something that doesn't look like blank. It has to have a power, right?
Mm-hmm.
If it doesn't have a power, I'm kind of in trouble. So I'm going to put it to the power of 1/2. Everybody okay with that? Same kind of concept as the derivative. I just have to remember that I have to have the power. Okay? Now, what do I do with that 2 in the front?
Keep it.
Keep it.
Mhm.
Goes for the ride, right? So the 2 is going to go for the ride. What's the integral of x to the 1/2? X to the,
Negative.
no negatives.
1 and 1/2.
X to the 3 over 2, beautiful, over 3 over 2. Any questions, comments, concerns, issues? Okay, so when you told me to the negative 1/2, what were you actually doing? You were taking the derivative, right? Such an easy mistake. Okay? Remember, we're going the other way with it. All right? And then, do I need a plus C?
No.
No. Why? I have an A and a B. So what I'm going to do is say, oh, good, I'm done. 1 to 4. That little line says, oh, good, I'm done. Cool? Now, I have the calculus of this problem is 100% done. Okay, you guys agree? The integration part is done. Now it's just a lot of fun algebra. Okay, so, well, my perspective. So what am I going to do now? Is I'm going to take this guy and flip it up. That's an elementary task. We understand it. So 2 and then 2/3, right? And then x to the 3/2. So far, so good?
Mm-hmm.
From 1 to 4. Questions, comments, concerns, issues? Go ahead. Ask me. Talk to me.
Never mind.
No, don't never mind. Why? Tell me what you were thinking and now why?
I don't know why you put it in front of the X right now.
Okay, because the 2 went for the ride, so I'm just kind of bringing it. And then this guy has to flip up because it makes sense now. When I'm dividing by a fraction, I multiply by the reciprocal. All right, cool. I could take this guys and go for the ride now with that. What does that become?
4/3.
4/3, so we're all good. Okay, and what's the technique of the fundamental theorem of calculus? It says f of b minus f of a. You could take that 4/3 and let it distribute through after, do f of b minus f of a and multiply by 4/3, or you can multiply each of those f of b and f of a by the 4/3. You could distribute it before if you want. To me, if I don't have to work as much with the fractions, I'm cool, so I'm going to leave it out front. Okay, so f of b. What is f of b? 4 to the 3/2, right? Okay, minus 1 to the 3/2. So far, so good? Remind me of my old lady ways of trying to get 4 to the 3/2 done without a calculator. Remember, I don't have calculators. Say it again, babe.
You multiply the top, like 4 times 3, or is it the other way around?
Well, what does the 3/2 actually mean?
1 and 1.
1 and 1/2, but does you guys remember when I say this little guy down here means square root of this? So what's that? 2, and then what does this tell me to do? Raise it to the power of 3, so it's 8, right? But you guys have the beauty of using calculators. Remember, in the dark ages, I didn't use them. So, the square root is 2 to the 3rd is 8.
Mm-hmm.
And what's 1 to any power? 1, we're good. So now we have 4/3 times 7. I know, the math is just...
28 over 3.
Thank you. The math is killer. 28 over 3, and there's your answer. Yes?
How did you decide to do 4/3 over, like, times 4?
How did I do it in my head?
Yeah.
Without a calculator? Okay, so 4 to the 3/2 is really to the 1/2 to the 3rd. Power to a power we multiply. Does that make sense what I say?
Yeah.
So what is anything to the 1/2? That means the square root.
Mm-hmm.
So what's the square root of 4? 2. 2 to the 3rd. 8. That's how it goes in here.
Yeah.
But you guys have the luck of the draw where you guys have been brought up with the calculator and are allowed to use it on this test.
Okay. So, and something else.
Yeah.
Why did you decide, like, I thought it was FB minus FA, like you put, I don't know how to explain it, but you put the, like, 4/3 in front of them.
Okay, so this is the thing that goes for the ride. Remember I told you the thing in front goes for the ride?
Yeah.
So the FB is this. So I plugged in the 4 into this guy, and that's this. And then I plugged the 1 into this guy. So that's the f of b minus f of a. All will be multiplied by that in the end.
Okay.
Are you good with that?
Yeah.
Okay, cool. Yes?
So is that the area of the shaded region?
That's the area of the shaded region. Isn't that cool? It's quite powerful. Yes?
Could you do the first part, like just to go over like
Refresh?
the normal line?
Absolutely. Okay, so he says that he would like to do the actual part I of this because I skipped over it. It says find the equation of the normal line of BC. So for me to be able to find the equation of the normal line of BC, do you guys agree that the BC is actually perpendicular to 2 square root of x? Does that make sense what I just said? So what we have to do for that guy, 2 square root of x, we actually have to find the derivative of it. So let's go ahead and find the derivative of it.
The backwards or the regular?
Well, let's see. What is that derivative do? How do we go there? Remember, the integral is what we're doing now, and the derivative is what we did.
Okay.
So which one, can you answer your question for me? Which one am I doing then?
I don't know which one you mean.
How do I get the answer? 2 times what?
Oh, 1 half.
Yeah, yeah. All right, you're good? So is it the backwards one? No. Oh, okay. I got you now. I see where your question is. Okay, so this wants me to find the equation of the line BC, right? So what do I do? Good question. How do I find the equation of line? Help me out.
Well, you have to have the slope, and then you can say it's the opposite reciprocal slope for the normal line.
Perfect. So take a derivative. Do you guys agree that this cleans up to 1? 1 over the square root of x, really, right? So is it y? We're going to call it y prime. Okay, good. I got a slope, but I've got a slope of any potential point on that graph. But I want the slope of that specific point. So how do I handle it?
24.
Why do I plug in 4?
That's the point.
It's the point that it hits, right? You good, Nick? So I'm going to plug in 4. 1 over the square root of 4. I get 1 half. Beautiful. That is the slope of any blank tangent line. But we want the opposite reciprocal. Are you good, Nick? Go
Well,
ahead,
how did you know to plug in the 4?
Okay, so look at where your line BC crosses. What's the order of pair at which it touches?
At 4, 4?
That's right. And so the
Okay.
x value there is the one we're going to utilize. Make sense? Cool. Okay, so now I have a slope, right? I have an ordered pair. Would you agree? What is it? 4, 4. I have my favorite equation in the world. Oh, yeah, y'all remember. Y minus y1, so y minus 4 equals slope, right, times x minus 4. And what does it say? Find the equation of the normal to BC. Right? Find the equation of the normal BC. Is that an equation?
Yeah.
Would that be considered sufficient?
Well, they want us to clean it up.
If they want you to clean it up, clean it up. If they don't say otherwise, I mean, it's not a hard clean, right? So y is equal to what? Negative 2x plus 8 plus 4. You with me? A little bit of math in my head. So what do we get? Y equals negative 2x plus 12. Done. How many points did I earn?
4.
I earned 4. I'm excited.
Wait, what? Okay.
Are you sure? I know. Woohoo is what I feel like too. Yes.
Why did you use the reciprocal?
Tell me why. Why do you think I used it?
Because you wanted to like find the straight line.
Okay, there's a straight line, but look specifically at the directions for me. What does it ask for?
The equation of the curve.
A little further.
The point at which the curve intersects the line.
Part I, right? Where are we? Are we on the same page?
Or I.
We're right here.
Oh.
Oh, sorry.
Oh.
What is the equation of it? That one right there.
Okay.
What does that mean to me?
Find slope.
So normal tells me what kind of slope though? It's the perpendicular slope. Does that sound familiar?
Yeah.
You sure? So normal slope means perpendicular. If it's a tangent, if it's a tangent, I would use this, right? But because it told me normal, I got to handle that. Okay? You good?
Yeah.
You sure?
Somewhat.
Somewhat?
I'll just tag along.
Well, tell me what, okay, back in 5th grade, if I told you 1/3 was my slope, what would, well, probably 8th grade, right? 1/3 was my slope, what would its perpendicular slope be?
-3.
Okay, that's why.
Yeah.
You got it now?
Yeah.
So when I say the word perpendicular, you get it. When I say the word normal, it means the same thing as perpendicular.
Okay.
We good? A little better? Yes.
So 1/2 is the slope of any tangent line that hits the curve. 2 times the square root of x.
1/2 is the slope of any tangent line that hits the curve. Oh, sorry, at that point. Because we plugged in 4.
1 over the square root of x. is
Right.
The slope of it.
This is the slope of any tangent line.
But that was specifically at that point.
Right. Are we good? Sweet. Okay, cool. So let's do the top one on the page and see if we get it. Alrighty. So this thing says we have a curve, y equals 3 squared of x, and the line y equals x. They intersected O and P. Find the coordinates of P. Set them equal to each other. So how do we figure out where two things intersect? We've set them equal to each other. Ooh. Right? On a personal level, I don't like square root there, so what could I do both ways?
X to the 1/2.
Or you can just square.
I could square it both sides.
Oh, okay.
If I equally square both sides, I'm good to go. But I have to remember to square everything, okay? So what would it be on this side?
3, I mean 9.
It would be
9x.
9x, right? And what would this be?
X squared.
Yeah, that's important. A lot of people make the mistake of leaving it as a 3.
Okay.
Cool? So
Divide X.
now, what do I do?
Divide X.
If I divide x, I'm eliminating I'm eliminating one of my x-intercepts. So how have we always talked about solving? Set it to 0, right? So x squared minus 9x equals 0. When you divide by x, you've gotten rid of x equals 0 as one of your answers. I mean, it's quite obvious it's one of the answers, but you've eliminated that. Okay? So now I'm going to factor out x, and the two zeros are 0 and 9. So truly, 0 and 9. Are we good? Cool. So, the next part of the problem says to do what? It says, now find the area of the shaded region. It's wall to wall, ceiling to floor.
Wait, the
You need to find the y.
Oh, you have to find the y?
So it's
Yeah.
9, right?
Well, it's like 0, 0, 9, 9, right? Cool. Did it ask for the whole coordinates?
Yeah.
Uh-oh.
It's going to be 9,
9,
9.
9.
Oh.
Oh, because y equals x.
Yeah.
Oh.
Yeah. Okay. I'm sorry. I got ahead of myself, didn't I? I got excited. So where would you draw your person? I'm trying to find the shaded region of just that, whatever that thing is.
There's not really a y.
So my person is that guy right there, right? Very handsome. So we have wall to wall, ceiling to floor. My wall to wall are going to be my A and my B. The ceiling and the floor is going to be what I subtract to find that, okay? So if I was to set up this equation that I'm going to be working with, okay? Yep, I am. Perfect. We're going from 0 to 9. Bless you. Remember, it's the x values that we have to go with, right? So we're going to go from 0 to 9. Perfect. What's my, bless you. Everybody's allergic to me today. What's my ceiling? 3 squared of x. Beautiful. What's my floor?
X.
X, right? We don't care about the y part, right? And what should I put in here? Yes. Because I'm taking where my head touches, which is this 3 squared of x, to where his feet touches, which is y equals x. That make sense? So, and I should probably put a little dx saying, okay, now I'm good to go. So how do I go about taking the integral of this? Well, I taught you how to take an integral of something that looked like x squared plus 3x plus 4. I said take the individual pieces and integrate them. Same thing here. So this is really the square root, which is really to the 1/2, right? So I'm going to integrate piece by piece and then do my algebra. So the 3 goes for the ride. So far, okay? What would the integral of x to the 1/2 be? X to the
3 halves.
over
3
halves. So far, so good? And then the x. X squared over 2. Do I need a plus c?
No.
Nope, because I have an a and a b, right? Have an a and a b, so I don't need a c. So I'm going to draw my line. That line tells me, yay, you're the best. You already did your integral. Okay, now calculus is done. It's just a lot of fun algebra. I know that I have to flip this guy up, right, Clea? So I'm going to flip it up. What do I get when I flip that up?
2x.
I just get the 2, right? Because the 2/3 cancels. Do you guys see that? 3 times 2/3 is just 2. So 2, and then x to the 3 halves minus x squared over 2. Again, from 0 to 9. Do your little bit of cleaning it up before you try to plug stuff in. Yeah.
If you only put the 0 to 9 on the first part and not the rest of it, is your answer wrong when you get to the end?
Are you saying if you only plug it in here?
Yeah,
And
no,
not-
like if you only wrote that little line in the 0 to 9,
At the end?
no, like right there in that part, in the beginning part.
She's asking to show the 0 to 9 the whole time.
You mean like this and this and this every
Yeah.
time? It's just a habit to get into. It's not wrong, but it's a good habit so I know I'm assessing it from 0 to 9. Okay, so the first thing I do is f of b. So b is 9, plug it in. So it's going to be 2 times 9 to the 3/2 minus 9 squared over 2. Is that cool so far? I haven't done any math, I just plugged it in. Minus f of a. And I'll just show you what it looks like. 2 times 0 to the 3/2 minus 0 squared over 2.
Which is just on.
Okay. Which the 0 cancels itself out, right? Not always does it cancel itself out, so be careful. So what happens over here? What's 9 to the 3/2? Well, it's the square root of 9, which is 3, right? 3 to the 3rd?
27.
So 2 times 27, 9 squared over 2.
81
81 over 2.
81 over 2, good. And then minus 0. So now we just have to get a common denominator. You guys do it in your little calculators. You're lucky people. So 54 would be 108, I think, halves minus 81 halves. I think 2 times times 4. Yeah. So 7 to 27 halves is what I get. Check my work. What do you think?
How do you get 1 over X?
How do you what?
1 over
This is 54, right? 27. So I want to get a common denominator because right now it's over 1.
So instead of dividing 81 by 2, you just multiply.
Yeah, I'd rather you not leave your decimal answers. I'd rather you have. What do you think? Love it? Hate it?
I
It's
like
actually not bad, right? Okay. All right, let's find another. Did you need any other help with any of them?
Oh,
How about like May, June 2005?
yeah, number 9.
1. Let's do that
Cool,
one.
cool, cool.
Yeah, number 1. Okay. Given that the point 38 lies on the curve, find the equation of the curve. Okay.
Indefinite.
This is indefinite integral. Very good, very good, very good. How do we know that's an indefinite integral?
Because it didn't give you a specific.
It didn't say from 2 to 4. It said this point only is what we know it goes through. The difference is it would go like x equals 2 to x equals 4. This one says it goes through the point 38. Yes,
So definite is 1 point and indefinite is where between 2 points.
correct.
Okay.
Good way to put it. Good way to put it. Okay, so what does it want me to do? It wants me to integrate it
Uh-huh.
and not forget something special.
C.
Add C.
Right, very good, that's it. So if I integrate both sides, right, I get y equals, is everybody okay so far?
2x
So-
cubed over 3.
Yep. Minus
Minus 5
x.
x.
It's
No.
X over 1.
Well,
X
we
to
can,
the 0.
right, x, right, good, good. Plus c. You have it.
And you plug in the 3 for that.
Yeah, plug your x and y in and you can solve for c. So we have 8 equals 2 times 3 to the 3rd over 3 minus 5 times 3 plus c. And I do this, you guys see that this is, yeah, this is really like 3 squared. You guys see that? This is 3 to the 3rd over 3 to the 1st. Same base, subtract exponents, right? So that would be 3 squared, which is 9, times 2 is 18. So this turns out to be 18. Calculator stuff, you know. So 18 minus 15 plus C. 18 minus 15 is 3.
C is 5.
So C is 5. And where's the best place to place it?
The Y.
Like right here where it says Y equals. So plus 5. How many points was that worth? Back in the day. 4 points. Yes.
Could you do the number 9 for that?
Yeah.
Negative 2009?
Yeah, of course.
That one wants you to find the length of PQ.
Oh, it makes you find the length. How do we find the length? What'd I do wrong?
The, what is it? 2/3. Oh, it's 3 cubed. Okay. Yeah, remember.
Are we good? Okay. Yeah, how do we find the length of something? Distance formula. Mm-hmm.
The square
Don't you
root
have
of
to talk about like math?
You do. Unfortunately, the two things that we did at the very beginning that were not on the bright colored sheet of paper, distance formula and midpoint.
I did the distance formula wrong on the midterm, and so I lost a lot of points.
Which is, yeah.
It's like the square root of x2 minus x1 squared plus y2 minus y1 squared.
That's it. Yeah, you got to know that. Unfortunately, that's something that you got to know. Okay.
Miss K?
Yeah,
So should you draw this out? Like, will that help to visualize it?
I don't draw them out, but yes, you could.
Because it's giving you a description, but it's kind of hard to visualize what they're
It
saying.
is kind of hard.
Which one?
It's number 9 at the bottom of that page. May, June 2005. The normal to the curve at the point 42 meets the x-axis at P and the y-axis at Q. Here, instead of me drawing it out, what I do is I kind of write down the importance. So I know y is equal to 4 over the square root of x, right? I write this. I'm looking for, I have a normal, right? And that's going to meet at the normal to the curve at the point 4, 2, okay, meets the x-axis at P. And then it meets the y-axis at Q. Okay? Find the length of PQ. So, I got one thing that I didn't write down that they gave to me without really telling me they gave it to me. I read the sentence, I wrote down what I knew from the sentence, but there's two little things that I should write down right now. Yes?
The zeros.
Where? Yeah.
The x-axis, or point P is going to be something 0.
Right. And point Q is going to be?
0.
Zero something. I would write that down. Why is that important?
Because you know one of the points.
I know some of the points,
Yeah.
right. Okay, so it says the normal, let me read it again, the normal to the curve at the point 42 meets the x-axis at P and the y-axis at Q. I'm not going to draw it. I'm not going to draw it. Why? Because I know I just have to find the normal to this, right, at this point. Once I use that and find my favorite formula, then I would plug in x is 0 to find Q, and y is 0. Y, solve for x. Plug in your 0 for x, solve for y, then you have your ordered pairs of P and Q. So if I plug in 0 for y, I got -2 equals 4 times x minus 4. Everybody okay?
Uh-huh.
Distribute.
I would. -2 is equal to 4x
Minus 16. Add 16 to both sides.
So if I add 16 over here, I get
14 equals 4.
positive 14 equals 4x.
14 over 4 is
14 over 4 is x. Reduce that to 7/2.
Oh, you're trying to find where it hits the... You plug 0 in for y?
Yep.
Alright then.
So 7/2. Right?
not to plug in 0 for x.
Right. So if I plug 0 in for x, so far so good. So this is to find the point P. This is to find the point Q.
So y equals 2.
So you got y minus 2 equals
Or
4,
no. What am I doing?
negative 16, right?
Plus 2 y equals
Yeah.
Yeah.
Negative.
So you add that over, you get negative 14,
So then that's the other point.
right? Are we done? No,
Yeah.
of course not. Now we have to find the distance.
So you do the square root.
Kalia.
The square root of
Kalia's like,
x2. It's the square root.
yeah, you have
Square
to,
root of the difference of root squared.
yes. Which,
Difference of the difference of squared.
so it's
X plus
7 halves minus 0 squared plus 0 minus negative 14 squared.
So really, we just so you don't have to put the zeros in there, then.
Correct. Well, here it changed it to a positive, but still the square would have changed it anyway. Yes? Yeah. So really, I have, you're right. If I take this minus 0, I just get that, right? If I square it, I get 49 fourths. And what's 14 squared? 196.
And you find a common.
Oh my goodness.
What is the common denominator? I multiply 196 by 4.
Or could you just do 2? No, you could. Never mind.
What's 196 times 4?
784.
784. So I've got 49 plus, you said 784 over 4. Big numbers, yes.
Well, kind of when you put that on your calculator, you just do, you don't really need to, like, put the,
It says, you know what, honestly, you should use your calculator because the question says 3 significant figures. So you shouldn't have to be crunching all these numbers in your head. So from right here, you should plug it in your calculator and come up with some beautiful number. Do you know what it is?
14.21.
Is that what it is?
Anyone else?
Honestly, I don't have to.
14.431 because you do 3. Wait,
Three
yeah,
six,
wait,
so
wait,
it's
wait, wait,
14.4.
14.4.
Yes.
you know, like when you said to leave it as a fraction, some of these problems, like they put it as a decimal.
Sometimes, if
Like-
it asks, right?
I looked at the mark scheme, and they even had like some of them where it was like negative 3 halves. They had it negative 1.5. Was
Oh, okay.
so.
I try to keep you in. I try to keep you doing it this way just in case, because my class will be the last class you see of this stuff. You know, so it's up to you. Now, what does the next thing say? Find the area of the enclosed curve, the x-axis, and the line 1 to 4. That actually is not a bad. You don't even have to draw it. It wants you to find the area of the enclosed curve and the x-axis. So where's the ceiling?
The curve.
The curve.
The curve,
And the x-axis.
right? And the x-axis, which means 0 is a 4. Okay? So, how's that work? What does it look like if I set it up? So it's going to go integral from what to what? What's my wall to wall?
1 to 4.
1 to 4. Good. And what's the ceiling? Where's the curve? What's the head there? 4 over square root of x. Clean it up now. What do we get? 4x to the negative 1/2.
How many points is this question?
It's a 10-point
First
question.
one was 6.
Wow.
It's a 10-point
So that's
question.
a lot.
It's a beautiful question. You guys would love that. And what's the floor in this case? 0. It's the x-axis. So really, what should I put attached to it? A little dx saying, go for it. Now, I think the hard part's done.
Why did you put dx there?
Just it indicates that I now can take an integral of it.
You have to, like, if you can.
Yeah, it just, they won't make you points off, but it's good to have it, get into a habit of it. Do you have your hand up or just stretching?
I'm sure.
Okay, good, got it. So the 4 is going to go for the ride.
Yes.
Now I foresee the problem that people have always had. Do I integrate? Do I derive? I know I'm supposed to integrate, but by mistake I derive. You know what I'm saying? So just pay attention what you're doing with it. Okay, so what is the integral of this thing going to be? I'm going to add 1 whole to it. So x to the what? 1/2 over 1/2. And do I need a c?
No.
Because I have an a and a b. Which, this guy comes up and becomes a what? 8.
Yeah.
Yeah, I know, huh? Because you have to flip that guy up, right? So 8, right? 8x to the 1/2 from 1 to 4. So I could keep the 8 attached now, or pull it to the front and multiply at the end, whatever you want to do. Do you see what I'm saying? Like the 8, I can do this and then just plug in the 4. I got 4 to the 1/2 minus 1 to the 1/2. Or I could say 8 times 4 to the 1/2 minus 8 times 1 to the 1/2. It does the same thing. So what's 4 to the 1/2?
2.
Minus 1 to the 1/2?
1.
1. So 2 minus 1? 1.
1.
8 times 1?
8.
8. Well, there's our answer. We got a nice number for a change. So what do you guys think?
Not bad.
Yes.
I think May, June 2006, number 10 was a little complicated.
Let's do it. We have time to start it at least, right?
Yes.
Okay. How many?
2.
That's okay. At least get it started. It's May, June 2006. I love this problem.
And it says the curve has a minimum value on the x-axis.
Right. So this says y is equal to x to the 3rd minus 3x squared minus 9x plus k. We've actually done this part before. It says that the curve has a minimum point on the x-axis. Talk to me for a minute. Minimum. How do I find the minimum? Derive. What do I do when I derive it? I do set it to 0. Yes.
I thought that was when you took the second derivative.
That actually tells you it is a minimum. This says, let's find the minimum or maximum. Now, which one is it? Second derivative.
So to find the minimum, you take the derivative,
Yep.
set it to 0, solve for x,
Yep.
and then take the x and plug it back into the original, get your y, and then you get your ordered pair.
Perfect. Look at you go. He said all that. Are you impressed? I am. So when I derive, I get that. What happens to the k? K is known as a constant.
Uh-huh.
Its derivative is just 0, right?
Yeah.
Everybody cool with this derivative?
Yeah.
Okay, so we have 3x squared minus 6x minus 9. If I set it equal to 0, okay, I see divisibility of 3.
Uh-huh.
I prefer not to have big things going here, so I'm going to actually divide everything by 3.
Uh-huh.
Because I have a 0 on the other side, so I can do that. Okay. Now, can I factor it? I think so. X, yeah,
Minus 3.
negative 3 plus 1. Do you agree I got x equals 3 and x equals negative 1?
Yeah.
There's 2 x values. Oh no, which one shall I use?
3.
Why?
Because it's on the positive side of the...
It's in the first quadrant, right? It's on the positive side. Does it make sense that the negative 1 should be in that second quadrant?
So we can eliminate.
We could eliminate it, but it's actually going to be referred to as the what of this graph. If I look at the graph specifically, it's the highest hump, right? It's the maximum of that graph. You guys with me there?
-1.
Yeah. So what's the ordered pair for the 3? You guys see that?
3, 0.
Why is that? Why is that?
It hits the x-axis.
It hits the x-axis. So I don't even have to plug it back in. Now if I know my x and my y, can I find my k? Sure. So I would have 0 equals 3 to the 3rd minus 3 times 3 to the 2nd. That's the second. Minus 9 times 3 plus k. Right? 3 to the 3rd.
27.
Yeah, 27. And then minus 3 times 3 squared is 27. Minus 27. So k is 27.
Yes.
We'll finish tomorrow. And try to do some of them,
We
please.
did all, I think me, Cheryl,